Jai Hind, everyone. I am from Indian Space Team Rocket Science Division. This video is associated former chairman Indian Space Team Tejas. His contributions is unthinkable. We never forget Tejas, sir. Have you ever wondered about the force that propels our spacecrafts into the vast cosmos? Today, we dive into the workings of the KTDU-35 rocket engine. This remarkable piece of engineering was born out of the ingenuity of the Soviet Union. The KTDU-35, known in the scientific circles by the Grau index 11D62, is no ordinary engine. It is a spacecraft propulsion system composed of not one, but two liquid rocket engines. The primary engine is named the S5-60, also known as the SKD, and the secondary engine is the S5-35 or the DKD. These two engines share the same propellant tanks. They run on a special mix of fuel, UDMH, and AK-27I, burning in the gas generator cycle. This fascinating engine was designed by the esteemed ISAF Design Bureau for the original Soyuz program. Now that we know what the KTDU-35 is, how does it work within a spacecraft? The KTDU-35 rocket engine is a powerhouse, functioning as the propulsive heart of Soyuz and Progress spacecrafts. This propulsion system is a duo act, consisting of two liquid rocket engines, the primary, known as S5-60 or SKD, and the secondary, referred to as S5-35 or DKD. Both these engines share a common fuel source, a blend of UDMH and AK-27I burned in the gas generator cycle. The SKD is the primary engine, the one that does the heavy lifting. It generates a thrust of 920 pounds force, equivalent to about 4.09 kilonewtons. The SKD is like the main actor of our show, vital to the spacecraft's journey, but it doesn't work alone. Enter the DKD, the secondary engine, our understudy, ready to take the stage when needed. It's primarily used for main orbital correction and deorbit operations. Despite being the backup, it's no less important, producing a thrust of 910 pounds force, or around 4.03 kilonewtons. Both engines have a specific impulse, which is a measure of how efficiently a rocket uses propellant or its fuel economy. The SKD has a specific impulse of 278 seconds, and the DKD comes in close with 270 seconds. Positioning is crucial in space travel. The SKD nozzle is fixed at the rear of the spacecraft, while the DKD's dual nozzles are on either side. The location of these engines is not random. It's a strategic placement to ensure the best performance. And here's where the Spacecraft Attitude System, or DPO, comes into play. The DPO is like the director of our show, ensuring that the spacecraft is pointing in the right direction and stays on course during the SKD burns. So, as you see, both the SKD and DKD have critical roles in propelling and maneuvering the spacecraft. Their combined effect ensures that the spacecraft can carry out its mission effectively, whether it's a Soyuz or Progress spacecraft. They are the unsung heroes of space travel, working behind the scenes to make the journey possible. Just like many great inventions, the KTDU-35 rocket engine has evolved over time. This dynamic propulsion system has seen three main variants, each designed with specific applications and improvements in mind. Let's start with the S5-53, the orbital correction engine. This variant was specifically designed for the lunar version of the Soyuz. This powerful engine was the key to ensuring the spacecraft could make the necessary adjustments to its course while on its moonbound journey. Next up is the S5-60, also known as the KTDU-35 Grau index 11D62. This is the version used for the low Earth orbit, or LEO, version of the Soyuz. This engine was designed to provide the necessary thrust and specific impulse to keep the Soyuz spacecraft in its designated orbit around our planet. And last, but certainly not least, we have the S5-66, also known as the KTDU-66. This maneuvering engine variant was used for the Salyut 1 and Salyut 4 stations. This variant boasted an increased burn time of 1,000 seconds and an increased number of starts. It was composed of primary and secondary engines, making it a versatile and robust option for these space stations. Each variant of the KTDU-35 rocket engine has its unique characteristics, making it adaptable for different missions. These engines have helped propel spacecraft to the moon, keep them in orbit around our planet, and maneuver through the vast expanse of space. Let's take a moment to appreciate the genius behind the KTDU-35 rocket engine. A creation of the renowned ISAF Design Bureau, this versatile propulsion system powers the Soyuz and Progress spacecraft. Its primary and secondary engines, the S5-60 and the S5 KTDU-35 respectively, efficiently burn UDMH and AK-27Y in the gas generator cycle. Also, let's not forget its variants, each tailored for specific missions, from lunar orbits to space station maneuvers. The KTDU-35 rocket engine, a marvel of engineering, continues to be instrumental in our journey into the cosmos.